Boyle's law expansion was that the maximum work available from any process is going to be available under what condition? What's the maximum work available from any process?
Well, reversible.
If it's reversible. And reversible means, in other words, we found that the work increased with the number of, when we did the expansion.
Microstate.
No, well, no, the number of, when we're doing an expansion, it was the work increased with the number of stages. So if I did a two-stage expansion, remember all that one, it's going to be in the next problem. We have 2 stages, we get so much work done. We have 3 stages, we get more work done. And the extension to a reversible is the extension to, is the extension to an infinite number of stages. And it requires that it is a continuous expansion. And that would be, in order for a process to be truly reversible, it would have to be continuous, and there would have to be no friction. In other words, the internal pressure of our piston containing our gas that we're expanding had to be equal to the external pressure for the entire time of the expansion. That would require that there was no friction. And so that's not physically possible to occur. There's always going to be a slighter excess of pressure internally to external pressure in order to overcome the frictional forces before the piston's going to start to move. And so we cannot have a truly reversible process. This represents the theoretical limit. And in our studies, and as will be revealed in the next problem, the maximum work is going to be for the reversible process, which is a theoretical limit. And that was what we used as the basis for the entropy, which Carnot came up with studying heat engines. And he found that delta S was equal to Q reversible over T, and that's going to be for equal to N R T natural log of V final over V initial under isothermal conditions divided by T. Okay, and that's equal to N R natural log of V final over V initial constant temperature for an isothermal expansion, which is what we were talking about, a Boyle's law expansion. Now, what you can do on the actual test, you don't need to include all this. It would be just delta S state is equal to NRL and V final over V initial. And then we can just plug it in, where N is the number of moles. And delta S is equal to 1 R natural log of 1/2. And that is equal to 1 R natural log of 2 minus 1. And here again, we're just going to pull this through because the rules of exponents allow us to. And that's equal to minus R natural log of 2, which agrees with the result we got from Boltzmann's approach, which was the reason we have this question. And so I guess, any questions about that? Okay. So that's a wrap.